Perl is a family of high-level, general-purpose, interpreted, dynamic programming languages. The languages in this family include Perl 5 and Perl 6. Though Perl is not officially an acronym, there are various backronyms in use, such as Practical Extraction and Reporting Language. Perl was originally developed by Larry Wall in 1987 as a general-purpose Unix scripting language to make report processing easier. Since then, it has undergone many changes and revisions. The latest major stable revision of Perl 5 is 5.20, released in May 2014. Perl 6, which began as a redesign of Perl 5 in 2000, eventually evolved into a separate language. Both languages continue to be developed independently by different development teams and liberally borrow ideas from one another. The Perl languages borrow features from other programming languages including C, shell scripting, awk, and sed. They provide powerful text processing facilities without the arbitrary data length limits of many contemporary Unix command line tools, facilitating easy manipulation of text files. Perl 5 gained widespread popularity in the late 1990s as a CGI scripting language, in part due to its parsing abilities. In addition to CGI, Perl 5 is used for graphics programming, system administration, network programming, finance, bioinformatics, and other applications. It is nicknamed the Swiss Army chainsaw of scripting languages, because of its flexibility and power, and possibly also because of its ugliness. In 1998, it was also referred to as the duct tape that holds the Internet together, in reference to both its ubiquitous use as a glue language and its inelegance. History: early versions. Wall began work on Perl in 1987, while working as a programmer at Unisys, and released version 1.0 to the Comp Sources MISC News Group on December 18, 1987. The language expanded rapidly over the next few years. Perl 2, released in 1988, featured a better regular expression engine. Perl 3, released in 1989, added support for binary data streams. Originally the only documentation for Perl was a single-man page. In 1991, Programming Perl, known to many Perl programmers as the Camel Book, because of its cover, was published and became the de facto reference for the language. At the same time, the Perl version number was bumped to 4, not to mark a major change in the language but to identify the version that was well documented by the book. Early Perl 5, Perl 4 went through a series of maintenance releases, culminating in Perl 4.036 in 1993. At that point, Wall abandoned Perl 4 to begin work on Perl 5. Initial design of Perl 5 continued into 1994. The Perl 5 porters mailing list was established in May 1994 to coordinate work on porting Perl 5 to different platforms. It remains the primary forum for development, maintenance, and porting of Perl 5. Perl 5.000 was released on October 17, 1994. It was a nearly complete rewrite of the interpreter, and it added many new features to the language, including objects, references, lexical variables, and modules. Importantly, modules provided a mechanism for extending the language without modifying the interpreter. This allowed the core interpreter to stabilize, even as it enabled ordinary Perl programmers to add new language features. Perl 5 has been in active development since then. Perl 5.001 was released on March 13, 1995. Perl 5.002 was released on February 29, 1996 with a new prototypes feature. This allowed module authors to make subroutines that behaved like Perl built-ins. Perl 5.003 was released June 25, 1996, as a security release. One of the most important events in Perl 5 history took place outside of the language proper and was a consequence of its module support. On October 26, 1995, the Comprehensive Perl Archive Network was established as a repository for Perl modules and Perl itself. As of March 2014, it carries over 129,703 modules, written by more than 11,274 authors, and is mirrored worldwide at more than 260 locations. Perl 5.004 was released on May 15, 1997, and included among other things the universal package, giving Perl a base object to which all classes were automatically derived and the ability to require versions of modules. Another significant development was the inclusion of the Cygwin module, which contributed to Perl's popularity as a CGI scripting language. Perl also now supported running under Microsoft Windows and several other operating systems. Perl 5.005 was released on July 22, 1998. This release included several enhancements to the regex engine, new hooks into the backend through the Dbi modules, the QA regex quote operator, a large selection of other new core modules, and added support for several more operating systems, including BOS 2000. Present, Perl 5.6 was released on March 22, 2000. Major changes included 64-bit support, Unicode string representation, large file support and the R keyword. When developing Perl 5.6, the decision was made to switch the versioning scheme to one more similar to other open-source projects. After 5.00563, the next version became 5.5.640, with plans for development versions to have odd numbers and stable versions to have even numbers. In 2000, Wall put forth a call for suggestions for a new version of Perl from the community. The process resulted in 361 RFC documents which were to be used in guiding development of Perl 6. In 2001, work began on the apocalypses for Perl 6, a series of documents meant to summarize the change requests and present the design of the next generation of Perl. They were presented as a digest of the RFCs, rather than a formal document. At this point, Perl 6 existed only as a description of the language. Perl 5.8 was first released on July 18, 2002, and had nearly yearly updates since then. Perl 5.8 improved Unicode support, added a new I/O implementation, added a new thread implementation, improved numeric accuracy, and added several new modules. As of 2013, this version still remains the most popular version of Perl and is used by Red Hat 5, SUSE 10, Solaris 10, HP UX 11.33 and AIX 5. In 2004, work began on the synopses documents that originally summarized the apocalypses, but which became the specification for the Perl 6 language. In February 2005, Audrey Tang began work on Pugs, a Perl 6 interpreter written in Haskell. This was the first concerted effort towards making Perl 6 a reality. This effort stalled in 2006. On December 18, 2007, the 20th anniversary of Perl 1.0, Perl 5.10.0 was released. Perl 5.10.0 included notable new features, which brought it closer to Perl 6. These included a switch statement, regular expressions updates, and the smart match operator. Around this same time, development began in earnest on another implementation of Perl 6 known as Reusable Perl, developed in tandem with the Parrot virtual machine. As of November 2009, Reusable Perl has had regular monthly releases and now is the most complete implementation of Perl 6. A major change in the development process of Perl 5 occurred with Perl 5.11. The development community has switched to a monthly release cycle of development releases, with a yearly schedule of stable releases. By the plan, bug fix point releases will follow the stable releases every 3 months. On April 12, 2010, Perl 5.12.0 was released. Notable core enhancements include new package name version syntax, the yada yada operator, implicit strictures, full Y2038 compliance, regex conversion overloading, DTRACE support, and Unicode 5.2. On January 21, 2011, Perl 5.12.3 was released. It contains updated modules and some documentation changes. Version 5.12.4 was released on June 20, 2011. The latest version of that branch, 5.12.5, was released on November 10, 2012. On May 14, 2011, Perl 5.14 was released. JSON support is built in as of 5.14.2. The latest version of that branch, 5.14.4, was released on March 10, 2013. On May 20, 2012, Perl 5.16 was released. Notable new features include the ability to specify a given version of Perl that one wishes to emulate, allowing users to upgrade their version of Perl, but still run old scripts that would normally be incompatible. Perl 5.16 also updates the core to support Unicode 6.1. On May 18, 2013, Perl 5.18 was released. Notable new features include the new DTRACE hooks, lexical subs, more coarse subs, overhaul of the hash for security reasons, support for Unicode 6.2. On May 27, 2014, Perl 5.20 was released. Notable new features include subroutine signatures, hash slices, new slice syntax, postfix dereferencing, Unicode 6.3, RAND using consistent random number generator. Some observers credit the release of Perl 5.10 with the start of the modern Perl movement. In particular, this phrase describes a style of development which embraces the use of the CPAN, takes advantage of recent developments in the language, and is rigorous about creating high-quality code. While the book Modern Perl may be the most visible standard-bearer of this idea, other groups such as the Enlightened Perl organization have taken up the cause. In late 2012 and 2013, several projects for alternative implementations for Perl 5 started, Perl 5 in Perl 6 by the Rakudo Perl team, Mo by Stefan Little and Friends, P2 by the Perl 11 team under Rainy Urban and GPERL by Gotchi. Name: Perl was originally named Perl. Wall wanted to give the language a short name with positive connotations. He claims that he considered every 3- and 4-letter word in the dictionary. He also considered naming it after his wife Gloria. Wall discovered the existing Perl programming language before Perl's official release and changed the spelling of the name. When referring to the language, the name is normally capitalized as a proper noun. When referring to the interpreter program itself, the name is often uncapitalized because most Unix-like file systems are case-sensitive. Before the release of the first edition of Programming Perl, it was common to refer to the language as Perl. Randall L. Schwartz, however, capitalized the language's name in the book to make it stand out better when typeset. This case distinction was subsequently documented as canonical. The name is occasionally expanded as Practical Extraction and Report Language, but this is a backronym. Other expansions have been suggested as equally canonical, including Wall's own humorous pathologically eclectic rubbish lister. Indeed, Wall claims that the name was intended to inspire many different expansions. Camel symbol. Programming Perl, published by O'Reilly Media, features a picture of a dromedary camel on the cover and is commonly called the Camel Book. This image of a camel has become an unofficial symbol of Perl as well as a general hacker emblem, appearing on t-shirts and other clothing items. O'Reilly owns the image as a trademark but licenses it for non-commercial use, requiring only an acknowledgement and a link to www.perl.com. Licensing for commercial use is decided on a case-by-case basis. O'Reilly also provides Programming Republic of Perl logos for non-commercial sites and Powered by Perl buttons for any site that uses Perl. Onion symbol. The Perl Foundation owns an alternative symbol, an onion, which it licenses to its subsidiaries, Perlmongers, Perl Monks, Perl.org, and others. The symbol is a visual pun on Perl onion. Overview. According to Wall, Perl has two slogans. The first is "There's more than one way to do it," commonly known as TMTOTI. The second slogan is "Easy things should be easy and hard things should be possible." Features. The overall structure of Perl derives broadly from C. Perl is procedural in nature, with variables, expressions, assignment statements, brace delimited blocks, control structures, and subroutines. Perl also takes features from shell programming. All variables are marked with leading sigils, which unambiguously identify the data type of the variable in context. Importantly, sigils allow variables to be interpolated directly into strings. Perl has many built-in functions that provide tools often used in shell programming such as sorting, and calling on operating system facilities. Perl takes lists from Lisp, hashes from awk, and regular expressions from sed. These simplify and facilitate many parsing, text handling, and data management tasks. Also shared with Lisp are the implicit return of the last value in a block, and the fact that all statements have a value, and thus are also expressions and can be used in larger expressions themselves. Perl 5 added features that support complex data structures, first-class functions, and an object-oriented programming model. These include references, packages, class-based method dispatch, and lexically scoped variables, along with compiler directives. A major additional feature introduced with Perl 5 was the ability to package code as reusable modules. Wall later stated that the whole intent of Perl 5's module system was to encourage the growth of Perl culture rather than the Perl core. All versions of Perl do automatic data typing and automatic memory management. The interpreter knows the type and storage requirements of every data object in the program. It allocates and frees storage for them as necessary using reference counting. Legal type conversions for example, conversions from number to string are done automatically at runtime. Illegal type conversions are fatal errors. Design. The design of Perl can be understood as a response to three broad trends in the computer industry: falling hardware costs, rising labor costs, and improvements in compiler technology. Many earlier computer languages, such as Fortran and C, aimed to make efficient use of expensive computer hardware. In contrast, Perl was designed so that computer programmers could write programs more quickly and easily. Perl has many features that ease the task of the programmer at the expense of greater CPU and memory requirements. These include automatic memory management, dynamic typing, strings, lists, and hashes, regular expressions, introspection, and an eval function. Perl follows the theory of no built-in limits, an idea similar to the 0-1 infinity rule. Wall was trained as a linguist, and the design of Perl is very much informed by linguistic principles. Examples include Huffman coding, good end weighting, and a large collection of language primitives. Perl favors language constructs that are concise and natural for humans to write, even where they complicate the Perl interpreter. Perl's syntax reflects the idea that things that are different should look different. For example, scalars, arrays, and hashes have different leading sigils. Array indices and hash keys use different kinds of braces. Strings and regular expressions have different standard delimiters. This approach can be contrasted with languages such as Lisp, where the same expression construct and basic syntax are used for many different purposes. Perl does not enforce any particular programming paradigm or even require the programmer to choose among them. There is a broad practical bent to both the Perl language and the community and culture that surround it. The preface to programming Perl begins, "Perl is a language for getting your job done." One consequence of this is that Perl is not a tidy language. It includes many features, tolerates exceptions to its rules, and employs heuristics to resolve syntactical ambiguities. Because of the forgiving nature of the compiler, bugs can sometimes be hard to find. Perl's function documentation remarks on the variant behavior of built-in functions in list and scalar contexts by saying, in general, they do what you want, unless you want consistency. No written specification or standard for the Perl language exists for Perl versions through Perl 5, and there are no plans to create one for the current version of Perl. There has been only one implementation of the interpreter, and the language has evolved along with it. That interpreter, together with its functional tests, stands as a de facto specification of the language. Perl 6, however, started with a specification, and several projects aim to implement some or all of the specification. Applications. Perl has many and varied applications, compounded by the availability of many standard and third-party modules. Perl has chiefly been used to write CGI scripts. Large projects written in Perl include cpanel, Bugzilla, RT, Twiki, and Movable Type. High-traffic websites that use Perl extensively include bbc.co.uk, Priceline.com, Craigslist, IMDb, LiveJournal, DuckDuckGo, Slashdot and Ticketmaster. It is also an optional component of the popular LAMP technology stack for web development, in lieu of PHP or Python. Perl is often used as a glue language, tying together systems and interfaces that were not specifically designed to interoperate, and for data munging, that is, converting or processing large amounts of data for tasks such as creating reports. In fact, these strengths are intimately linked. The combination makes Perl a popular all-purpose language for system administrators, particularly because short programs, often called one-liner programs, can be entered and run on a single command line. Perl code can be made portable across Windows and Unix. Such code is often used by suppliers of software to simplify packaging and maintenance of software build and deployment scripts. Graphical user interfaces may be developed using Perl. For example, Perl TK and WX-Perl are commonly used to enable user interaction with Perl scripts. Such interaction may be synchronous or asynchronous, using callbacks to update the GUI. Implementation: Perl is implemented as a core interpreter, written in C, together with a large collection of modules, written in Perl and C. As of 2010, the stable version is 16.53 MB when packaged in a tar file and gzip compressed. The interpreter is 150,000 lines of C code and compiles to a 1 MB executable on typical machine architectures. Alternatively, the interpreter can be compiled to a link library and embedded in other programs. There are nearly 500 modules in the distribution, comprising 200,000 lines of Perl and an additional 350,000 lines of C code. The interpreter has an object-oriented architecture. All of the elements of the Perl language are Euroscalars, arrays, hashes, caderefs, file handlers are represented in the interpreter by C structs. Operations on these structs are defined by a large collection of macros, typedefs, and functions. These constitute the Perl C API. The Perl API can be bewildering to the uninitiated, but its entry points follow a consistent naming scheme, which provides guidance to those who use it. The life of a Perl interpreter divides broadly into a compile phase and a run phase. In Perl, the phases are the major stages in the interpreter's life cycle. Each interpreter goes through each phase only once, and the phases follow in a fixed sequence. Most of what happens in Perl's compile phase is compilation, and most of what happens in Perl's run phase is execution, but there are significant exceptions. Perl makes important use of its capability to execute Perl code during the compile phase. Perl will also delay compilation into the run phase. The terms that indicate the kind of processing that is actually occurring at any moment are compile time and runtime. Perl is in compile time at most points during the compile phase, but compile time may also be entered during the run phase. The compile time for code in a string argument passed to the eval built-in occurs during the run phase. Perl is often in runtime during the compile phase and spends most of the run phase in runtime. Code in begin blocks executes at runtime but in the compile phase. At compile time, the interpreter parses Perl code into a syntax tree. At runtime, it executes the program by walking the tree. Text is parsed only once, and the syntax tree is subject to optimization before it is executed, so that execution is relatively efficient. Compile time optimizations on the syntax tree include constant folding and context propagation, but peephole optimization is also performed. Perl has a Turing-complete grammar because parsing can be affected by runtime code executed during the compile phase. Therefore, Perl cannot be parsed by a straight lex-yak-lexer parser combination. Instead, the interpreter implements its own lexer, which coordinates with a modified GNU Bison parser to resolve ambiguities in the language. It is often said that only Perl can parse Perl, meaning that only the Perl interpreter can parse the Perl language, but even this is not, in general, true. Because the Perl interpreter can simulate a Turing machine during its compile phase, it would need to decide the halting problem in order to complete parsing in every case. It is a long-standing result that the halting problem is undecidable, and therefore not even Perl can always parse Perl. Perl makes the unusual choice of giving the user access to its full programming power in its own compile phase. The cost in terms of theoretical purity is high, but practical inconvenience seems to be rare. Other programs that undertake to parse Perl, such as source code analyzers and auto-indenters, have to contend not only with ambiguous syntactic constructs but also with the undecidability of Perl parsing in the general case. Adam Kennedy's PPI project focused on parsing Perl code as a document, instead of parsing Perl as executable code. It was Kennedy who first conjectured that parsing Perl suffers from the halting problem, which was later proved. Perl is distributed with over 250,000 functional tests for core Perl language and over 250,000 functional tests for core modules. These run as part of the normal build process and extensively exercise the interpreter and its core modules. Perl developers rely on the functional tests to ensure that changes to the interpreter do not introduce software bugs. Additionally, Perl users who see that the interpreter passes its functional tests on their system can have a high degree of confidence that it is working properly. Availability: Perl is dual licensed under both the Artistic License and the GNU General Public License. Distributions are available for most operating systems. It is particularly prevalent on Unix and Unix-like systems, but has been ported to most modern platforms. With only 6 reported exceptions, Perl can be compiled from source code on all POSIX-compliant, or otherwise Unix-compatible platforms. Because of unusual changes required for the Mac OS Classic environment, a special port called MacPerl was shipped independently. The comprehensive Perl Archive Network carries a complete list of supported platforms with links to the distributions available on each. CPAN is also the source for publicly available Perl modules that are not part of the core Perl distribution. Windows: users of Microsoft Windows typically install one of the native binary distributions of Perl for Win32, most commonly Strawberry Perl or Active Perl. Compiling Perl from source code under Windows is possible, but most installations lack the requisite C compiler and build tools. This also makes it difficult to install modules from the CPAN, particularly those that are partially written in C. Active Perl is a closed-source distribution from Active State that has regular releases that track the core Perl releases. The distribution also includes the Perl Package Manager, a popular tool for installing, removing, upgrading, and managing the use of common Perl modules. Included also is Perl Script, a Windows script host engine implementing the Perl language. Visual Perl is an active state tool which adds Perl to the Visual Studio.NET development suite. Strawberry Perl is an open-source distribution for Windows. It has had regular, quarterly releases since January 2008, including new modules as feedback and requests come in. Strawberry Perl aims to be able to install modules like standard Perl distributions on other platforms, including compiling XS modules. The Cygwin Emulation layer is another way of running Perl under Windows. Cygwin provides a Unix-like environment on Windows, and both Perl and CPAN are available as standard pre-compiled packages in the Cygwin setup program. Since Cygwin also includes GCC, compiling Perl from source is also possible. A Perl executable is included in several Windows resource kits in the directory with other scripting tools. Implementations of Perl come with the MKS Toolkit and UWIN. Database interfaces: Perl's text handling capabilities can be used for generating SQL queries. Arrays, hashes, and automatic memory management make it easy to collect and process the returned data. For example, in Tim Bunce's Perl Dbi application programming interface, the arguments to the API can be the text of SQL queries. Thus it is possible to program in multiple languages at the same time. The use of Perl variable interpolation to programmatically customize each of the SQL queries, and the specification of Perl arrays or hashes as the structures to programmatically hold the resulting datasets from each SQL query, allows a high-level mechanism for handling large amounts of data for post-processing by a Perl subprogram. In early versions of Perl, database interfaces were created by relinking the interpreter with the client-side database library. This was sufficiently difficult that it was done for only a few of the most important and most widely used databases, and it restricted the resulting Perl executable to using just one database interface at a time. In Perl 5, database interfaces are implemented by Perl Dbi Modules. The Dbi module presents a single, database-independent interface to Perl applications, while the DBD modules handle the details of accessing some 50 different databases. There are DBD drivers for most ANSI-SQL databases. DBI provides caching for database handles and queries, which can greatly improve performance in long-lived execution environments such as mod_Perl, helping high-volume systems avert load spikes as in the /. effect. In modern Perl applications, especially those written using web application frameworks such as Catalyst, the DBI module is often used indirectly via object relational mappers such as Dbix class DBI or RoseDB object, which generate SQL queries and handle data transparently to the application author. Comparative Performance, the computer language benchmarks game, a project hosted by Alioth, compares the performance of implementations of typical programming problems in several programming languages. The submitted Perl implementations typically perform toward the high end of the memory usage spectrum and give varied speed results. Perl's performance in the benchmarks game is typical for interpreted languages. Large Perl programs start more slowly than similar programs in compiled languages because Perl has to compile the source every time it runs. In a talk at the YAPC Europe 2005 conference and subsequent article A Timely Start, Jean-Louis Leroy found that his Perl programs took much longer to run than expected because the Perl interpreter spent significant time finding modules within his overlarge include path. Unlike Java, Python, and Ruby, Perl has only experimental support for pre-compiling. Therefore Perl programs pay this overhead penalty on every execution. The run phase of typical programs is long enough that amortized startup time is not substantial, but benchmarks that measure very short execution times are likely to be skewed due to this overhead. A number of tools have been introduced to improve this situation. The first such tool was Apache's mod_Perl, which sought to address one of the most common reasons that small Perl programs were invoked rapidly, CGI web development. ActivePerl, via Microsoft IS API, provides similar performance improvements. Once Perl code is compiled, there is additional overhead during the execution phase that typically isn't present for programs written in compiled languages such as C or C++. Examples of such overhead include bytecode interpretation, reference counting, memory management, and dynamic type checking. Optimizing, because Perl is an interpreted language, it can give problems when efficiency is critical. In such situations, the most critical routines can be written in other languages such as C, which can be connected to Perl via simple inline modules, or the more complex but flexible access mechanism. Perl 6. At the 2000 Perl conference, John Orwant made a case for a major new language initiative. This led to a decision to begin work on a redesign of the language, to be called Perl 6. Proposals for new language features were solicited from the Perl community at large, which submitted more than 300 RFCs. Wall spent the next few years digesting the RFCs and synthesizing them into a coherent framework for Perl 6. He has presented his design for Perl 6 in a series of documents called Apocalypses, numbered to correspond to chapters in Programming Perl. As of January 2011, the developing specification of Perl 6 is encapsulated in design documents called Synopses, numbered to correspond to Apocalypses. Perl 6 is not intended to be backward compatible, although there will be a compatibility mode. Perl 6 and Perl 5 are distinct languages with a common ancestry. Thesis work by Bradley M. Kuhn, overseen by Wall, considered the possible use of the Java virtual machine as a runtime for Perl. Kuhn's thesis showed this approach to be problematic. In 2001, it was decided that Perl 6 would run on a cross-language virtual machine called Parrot. This will mean that other languages targeting the Parrot will gain native access to CPAN, allowing some level of cross-language development. In 2005, Audrey Tang created the PUGS project, an implementation of Perl 6 in Haskell. This acted as, and continues to act as, a test platform for the Perl 6 language, allowing the language designers to explore. The PUGS project spawned an active Perl Haskell cross-language community centered around the Freenode Perl 6 IRC channel. As of 2012, a number of features in the Perl 6 language show similarities to Haskell. As of 2012, Perl 6 development centers primarily around two compilers, Reusable Perl 6, an implementation running on the Parrot virtual machine and the Java virtual machine. Developers are also working on MOARVM, a C language-based virtual machine designed specifically for Reusable. Nyacha, which targets the common language runtime. Future of Perl 5, development of Perl 5 is also continuing. Perl 5.12.0 was released in April 2010 with some new features influenced by the design of Perl 6, followed by Perl 5.14.1, Perl 5.16.1, and Perl 5.18.0. Perl 5 development versions are released on a monthly basis, with major releases coming out once per year. Future plans for Perl 5 include making the core language easier to extend from modules, and providing a small, extensible meter-object protocol in core. The relative proportion of searches for Perl programming, as compared with similar searches for other programming languages, steadily declined from about 10% in 2005 to about 2% in 2011, and has remained around the 2% level since. Perl community. Perl's culture and community has developed alongside the language itself. Usenet was the first public venue in which Perl was introduced, but over the course of its evolution, Perl's community was shaped by the growth of broadening Internet-based services including the introduction of the World Wide Web. The community that surrounds Perl was, in fact, the topic of War's first State of the Onion talk. State of the Onion is the name for Walla unregistered trademark's yearly keynote-style summaries on the progress of Perl and its community. They are characterized by his hallmark humor, employing references to Perl unregistered trademark's culture, the wider hacker culture, Walla unregistered trademark's linguistic background, sometimes his family life, and occasionally even his Christian background. Each talk is first given at various Perl conferences and is eventually also published online. Perl pastimes, JAPHs, in email, Usenet, and message board postings, just another Perl hacker programs are a common trend, originated by Randall L. Schwartz, one of the earliest professional Perl trainers. In the parlance of Perl culture, Perl programmers are known as Perl hackers, and from this derives the practice of writing short programs to print out the phrase "just another Perl hacker." In the spirit of the original concept, these programs are moderately obfuscated and short enough to fit into the signature of an email or Usenet message. The canonical JAPH as developed by Schwartz includes the comma at the end, although this is often omitted. Perl Golf. Perl Golf is the pastime of reducing the number of characters used in a Perl program to the bare minimum, much in the same way that golf players seek to take as few shots as possible in a round. The phrase's first use emphasized the difference between pedestrian code meant to teach a newcomer and terse hacks likely to amuse experienced Perl programmers, an example of the latter being JAPHs that were already used in signatures in Usenet postings and elsewhere. Similar stance had been an unnamed pastime in the language APL in previous decades. The use of Perl to write a program that performed RSA encryption prompted a widespread and practical interest in this pastime. In subsequent years, the term code golf has been applied to the pastime in other languages. A Perl Golf apocalypse was held at Perl Conference 4.0 in Monterey, California in July 2000. Obfuscation. As with C, obfuscated code competitions were a well-known pastime in the late 1990s. The Obfuscated Perl Contest was a competition held by the Perl Journal from 1996 to 2000 that made an arch virtue of Perl's syntactic flexibility. Awards were given for categories such as Most Powerful Euro Programs that made efficient use of Spartiate Euro, and Best 4-Line Signature for programs that fit into 4 lines of 76 characters in the style of a Usenet signature block. Poetry. Perl poetry is the practice of writing poems that can be compiled as legal Perl code, for example the piece known as Black Perl. This hobby is made possible by the large number of English words that are used in the Perl language. New poems are regularly submitted to the community at Perl Monks. Perl on IRC. There are a number of IRC channels that offer support for the language and some modules. CPAN Acme. There are also many examples of code written purely for entertainment on the CPAN. Lingua Romana Perligator, for example, allows writing programs in Latin. Upon execution of such a program, the module translates its source code into regular Perl and runs it. The Perl community has set aside the Acme namespace for modules that are fun in nature. Some of the Acme modules are deliberately implemented in amusing ways. This includes Acme Bleach, one of the first modules in the Acme namespace, which allows the program source code to be whitened, and yet still work. Example code: in older versions of Perl, one would write the Hello World program as. In later versions, which support the say statement, one can also write it as. Good Perl practices require more complex programs to add the use strict and use warnings. Pragmas, leading into something like. Here is a more complex Perl program that counts down the seconds up to a given threshold. The Perl interpreter can also be used for one-off scripts on the command line. The following example is invoked from ANSH-compatible shells such as bash translates the string bob in all files ending with txt in the current directory to Robert. Criticism: Perl has been referred to as line noise by some programmers who claim its syntax makes it a write-only language. The earliest such mention was in the first edition of the book Learning Perl, a Perl 5 tutorial book written by Randall L. Schwartz, in the first chapter of which he states, "Yes, sometimes Perl looks like line noise to the uninitiated, but to the seasoned Perl programmer, it looks like checksum line noise with a mission in life." He also stated that the accusation that Perl is a write-only language could be avoided by coding with proper care. The Perl overview document Perl intro states that the names of built-in magic scalar variables look like punctuation or line noise. The Perl style document states that line noise in regular expressions could be mitigated using the /x modifier to add white space. According to the Perl 6 FAQ, Perl 6 was designed to mitigate the usual suspects that elicit the line noise claim from Perl 5 critics, including the removal of the majority of the punctuation variables, and the sanitization of the regex syntax. The Perl 6 FAQ also states that what is sometimes referred to as Perl's line noise is the actual syntax of the language, just as gerunds and prepositions are a part of the English language. In a December 2012 blog posting, Chromatic stated that the design of Perl 6 is a well-defined grammar that mitigates the issue of line noise via an improved type system, a unified object system with an intelligent mutamiddle, mta operators, and a clearer system of context which provides for such niceties as pervasive laziness. He also stated that Perl 6 has a coherence and a consistency that Perl 5 lacks. See also: Outline of Perl, Perl Data Language, Perl Object Environment, Plain old documentation, references. Further reading: Learning Perl 6th edition, O'Reilly. Beginner Level Introduction to Perl. Beginning Perl 1st edition, Rogues. A beginner's tutorial for those new to programming or just new to Perl. Modern Perl 2nd edition, Onyx Neon. Describes modern Perl programming techniques. Programming Perl 4th edition, O'Reilly. The Definitive Perl Reference. Effective Perl Programming 2nd edition, Addison Wesley. Intermediate to Advanced Level Guide to Writing Idiomatic Perl. Perl Cookbook, ISBN 0-596-00313-7. Practical Perl Programming Examples. Dominus, Mark Jason. Higher Order Perl. Morgan Kaufman. ISBN A1-55860-701-3. Functional Programming Techniques in Perl. External links: official website perl.org, Meta CPAN, the new Comprehensive Perl Archive Network web interface, Comprehensive Perl Archive Network, the canonical location for Perl code and modules, the Perl Foundation, Perl Monks, a community committed to sharing Perl knowledge and coding tips.